So we're going to start real quickly just talking about in connectivity with the software-defined vehicle, what we think are the most important issues. And the first most significant issue is scalability. And so we just want to talk a little bit about what we mean by scalability in the software-defined vehicle and in connectivity. So there's several aspects to scaling. There's scaling within the vehicle. So if we think in terms of the IoT vernacular, the Internet of Things, the perspective here is the car is not the thing. The braking controller is the thing. The steering controller, the autonomous driving platform. How do we reach those and provide a connective solution? So scaling to the complexity within the vehicle is the first challenge. And the technology we're going to show you here is deployed in millions of vehicles around the world. And sometimes it's reaching just one device in the vehicle, and sometimes it's reaching more than 60 devices in the vehicle. It's all real, it's all working today. Scaling across platforms. The architecture, the electronic architecture of the car is changing. So we have vehicles now that are moving towards gateway-based platforms for connectivity, vehicles that are moving towards domain master platforms, and the newest platform concept is the zonal controller platform, where we're working with generic processing resources and external I/O. All of these work with the connective solution I'm going to describe for you. So we have the opportunity to scale across platforms. When you do that, you provide the ability to scale across product families. So an automaker may have dozens of brands, models, submodels. When you put together the different build packages and options, that may be hundreds of different SKUs. And the question is, can you provide one connectivity solution to scale across that level of complexity? And that's exactly what I'm going to show you in this presentation. And then you want to scale not only at the vehicle level, but in the cloud. And of course, that's why we're here at AWS talking about it. And we're going to go through what it takes to make scalability in the cloud on an on-demand basis. So you're not scaling your costs, you're scaling your reach. And how to do that globally with the global reach of AWS. And then, of course, when we do all of that right, what we also provide are the mechanisms to scale your revenues. And so we're going to talk a little bit about that. So now you have the connection to the devices in the vehicle. You can reduce your costs on recalls. You can add to your revenues by enhancing the functionality of the vehicles, including adding new features to the vehicles after sale, features on demand, and even features that may be achieved through subscriptions. We'll talk about all of that. All of these capabilities to give you the scalability for today and tomorrow are already in the package that we're going to describe, and you'll see how they work. This is scaling through standardization. This is not a walled garden. This is not a closed proprietary approach. The approach of my company, Excelfore, is always based on standards where we can find them and creating standards where we can't find them. And so we're going to see all of that. Just a real quick statement. I said this is a technology that's proven in the field. It's already in millions of vehicles around the world. Just some examples of use cases. Suzuki is using this in about 500,000 vehicles in the programs using eSync all across Asia. Audi is using it to reach now programs that reach millions of vehicles, and these vehicles in 3 different continents. So this concept of reach to the magnitude of the vehicle fleet and the reach globally is all demonstrated in real practical applications. Plus, which provides autonomous driving technology for long-haul trucks, now has a partnership with Amazon for the long-haul Amazon trucks. They're using this technology to enhance the autonomous driving technology on a continuous basis, updating the technology in the platforms to learn over time and become ever better. And just to give you an idea how easy it is to deploy this, because it's a mature and working solution, the whole program to put this into the technology was completed in just 2 months' time. VinFast, the newest entrant to the North American, to the American automobile market, just received approval to begin selling their vehicles last week. And they're using eSync in their vehicles not only for over-the-air updates, but for managing features by subscription. so that you can buy the car and enhance the features of your car over time by subscribing to new features and having those features installed on the car at your home. So this is real use case examples, actual commercial deployments. And so now we're going to talk a little bit about how it works. It starts with a data pipeline. So we're building a data pipeline to all of the edge devices in the car. And this data pipeline is referred to as eSync. And this is defined in a standard published by the eSync Alliance, which is an automotive trade association. It's open to all members of the automotive ecosystem, and we encourage you to look at the eSync Alliance and come and join us and learn about the eSync specifications. My company, Excelfore, has a full implementation of the eSync stack. The eSync architecture is a server client agent architecture. It's all software. You can choose the hardware devices you want. And the idea here is the server in the cloud, the client for the vehicle, and then agents for the devices. And all of the unique characteristics of so many different devices in the vehicle get encapsulated into the agent for that device, so that you don't have to change the data pipeline when you're going to devices of vastly different capabilities. You provide an agent for that device, and the client knows how to talk to an agent. This is defined in the eSync specifications, and Excelfore offers a full working implementation. We then add on to that our OTA campaign manager. All of these are things you'll see in the presentation and we'll be showing you. We add the OTA campaign manager. We add a data aggregation platform, which we call eDatX, which helps us draw deep data from the devices in the vehicle, both for learning purposes, for observation purposes, for tracking the behavior and capabilities of your fleet, all the way down to the individual vehicle. We add on to that Fleet View, which gives you the tools to manage a fleet of hundreds of thousands or millions of vehicles, all software-defined vehicles with different versions of software and different devices in different domains across those vehicles. And then the Subscription Manager, which gives you a different pathway to implement the over-the-air updates to the vehicle, a pathway based on feature subscriptions, so that your end user, your customer, can subscribe to a feature, and that can drive this whole pipeline to install those features in the vehicle. So all of these we're going to be talking about today. And I encourage you, as we go through the conversation, speak up if there's something here that's of particular interest, and we'll get into it a little bit more deeply. So to go through it, what we're going to talk about: the data pipeline itself, eSync; the data aggregation platform, eDatX; the subscription manager for features on demand; Fleet View for the software-defined vehicle; eSync in the AWS cloud, how it's implemented in the cloud, which of the AWS cloud tools make this work for global scalability; parity with digital twins for your continuous innovation, continuous development environment, so that you can do a digital twin on the cloud and use one mechanism for software distribution for your development environment, your testing environment, and your commercial deployment environment. The same software distribution mechanism to reach all of those. And then how to get started. We have an SDK available in the AWS marketplace, and we'll talk a little bit about how you can get up and get going and have it working, a full data pipeline working in one day. So we'll go through all of these, but again, I encourage you to join in the conversation. We're going to start with the basics of the eSync data pipeline. So right now we're looking just at this portion of the solution set. The eSync data pipeline gives you a single construct for bidirectional data communications to the edge devices. It's a highly secure platform to reach everything from the smallest programmable device with a small RTOS or even bare metal, up to the biggest and most sophisticated computing platform with hypervisors and multiple virtual machines. To eSync, it's all an agent, and eSync knows how to talk to an agent. So you get the advantage of standardization. This whole pipeline is built in compliance with the specifications published by the eSync Alliance. It's highly structured. That helps in the implementation. because you know how it's a disciplined approach, and that's part of what speeds the implementation. There's a very high level of reuse, so as you scale across multiple projects and multiple vehicles, the second, the third, the fourth time, it becomes very easy and quick to implement. And it takes a standard in-vehicle infrastructure and gives you the flexibility to build that same infrastructure across widely diverse vehicles. So, you're going to have microcontrollers, microprocessors, virtual machines, service-oriented architectures. All of that can be reached through eSync. You're going to work on Linux and Android and QNX and Integrity and Adaptive AutoSAR and Classic AutoSAR, FreeRTOS, Erica, Nucleus, all of these different operating systems, already proven, working, demonstrated solutions are available in eSync. Reaching virtually any number of devices in the vehicle, virtually any number of vehicles all around the world. And you get full logs and records to help you with both your own support, but also compliance to the regulations that are emerging for this level of technology in different geographies around the world. eSync has a policy-based construct, and you'll see me talking more about that, so that you can guide the behavior of the pipeline to fit policies that are appropriate to the vehicle, policies that are appropriate to the edge device. You may want to treat your braking controller differently than your seat warmer in terms of what is considered a safe state of the vehicle for installing new software, and for different geographies around the world. You may find the regulatory environment in Europe is different than in North America, the United States is different than in China. eSync can deploy in all of those in all of those regions and give you compliant performance. The core is the in-vehicle infrastructure of the client and the agents. And the idea here is the client is standard and the agent is customizable. And so the client is going to handle the vehicle over tasks, the orchestration of the OTA process. The agent is going to handle its individual device or devices. And so in the agent, you will be customizing your device programming interface. The model of eSync is not to tell you you have to get devices that are programmed this way. It's to build an agent for that device that respects the way that device is programmed, that respects the way the OS works on that device. You can use standards like UDS or KWP 2000 for flashing the device, or you can use OS-specific things. Android has their way of doing it, Integrity has their way of doing it, or if you have a bare metal platform, how is it that you flash that device? Write that into your agent and you're ready to go. You get the control for the installation process, because how you do a reflash is different if you have a file system, if you're doing configuration files, if you're reflashing the OS or a partition of the OS. How you process that is different in different devices. Some operating systems have flat and no file structure. You're going to do an OTA update differently than in a device that has a sophisticated POSIX operating system. Again, that's all encapsulated into the agent. So the agent is going to work almost like an abstraction layer to take the unique characteristics of the device and turn it into the common correspondence of the eSync data pipeline. And then that agent travels with that device. So if you take that braking controller from one vehicle and put it in the next vehicle, take the agent with it, and it just connects straight into the eSync platform of that next vehicle. As I said, this is all published in the specifications of the eSync Alliance. So I encourage you to look into the eSync Alliance. Excelfore, my company, is one of the founding members. There were 5 companies that came together to build this alliance. There are now many companies in the alliance, all from the automotive ecosystem. We have semiconductor and automaker companies in the eSync Alliance, but the face of the eSync Alliance really is the tier 1s, the major companies building the edge devices in automotive, who are looking for a common way to plug into a data pipeline, because the guy who makes the ride leveling system is a long way from the cloud, but he'd like to access connected services. And eSync provides that capability. So now let's look at the data aggregation. This is our eDatX platform that Excelfore adds to the eSync platform. So now what we're doing is we're taking the basic eSync pipeline and we're adding the data aggregation. And we have an in-vehicle component and a cloud component. The in-vehicle component is a service to the eSync client. The cloud is it's a data lake in the AWS cloud. So in the vehicle, the eDatX service is going to provide rolling buffers to store full resolution data from the car, typically 15, 30, or 60 seconds of data. Then we do a granularity reduction. We do basic statistical or logical operations on the data to reduce the quantity of data by reducing the resolution of the data. And I'll show you some of how that works as we go through it so you'll get an idea what we're speaking of. But this is where we can reduce the data by up to 2 or 3 orders of magnitude so that you're not sending mountains of data from every car all the time. You're sending the useful data. You're sending the average values. You're sending the event values. You can set your triggers as a policy. When do you get the full resolution data? When do you get the reduced granular data? You can stream the data or you can aggregate the data into large bulk file transfers to send once a day, once a week, once a month, however you might like. So that's all built into the eSync service within the vehicle. And then in the cloud, we have the data lake and we have the visualization tools to feed to your web application. And I'm showing you here an example of another eDatX demonstration that's operating here at the show today. And I'm actually logged into it on the right. So we're actually looking at eDatX data live from the Green Hills, the GHS booth. And the Green Hills platform has all of these different devices with the Excelfore eSync and eDatX implementation in the different Green Hills operating systems. And I'm sorry, did you want to get a picture of that? And so this gives you kind of an idea of the structure of the software, and it's all hosted on the Amazon Web Services cloud. And it's live and working down at the Green Hills booth, and I urge you to go take a look. What you'll see there is a dashboard with basic monitoring information. You have in the visualization basic telematics information, but you're also getting some deep data. How is the radar performing? They have a driver alertness monitoring system implemented, and you can see how the monitoring system is observing. Is it getting a good track on the face? Is it able to track where the eyes are going? And the alert metrics that it generates, if it's seeing signs of a drowsy driver, all of that information being taken live down at the GHS booth, and I invite you to go down and take a look at that. We also have other deep data that may be used for health of vehicle and improvement of the vehicle, in this case looking at the battery management system. And so in this case we're looking at how efficiently are we managing an electric vehicle battery array of 96 battery cells. And what we've got going in this case, we're taking the min and max voltages, the min and max temperatures, and then we're reporting which cell, so we're tagging cell number with the min and max values, and then throwing away the rest of the values. This is an example of data reduction. What we're interested in is which cell has the highest voltage, which cell has the lowest voltage, which cell has the highest temperature, which cell has the lowest temperature. This helps us know how well our battery management system is performing in the field, in real life. And we're seeing a correlation here, that the minimum temperature battery cell correlates highly with the minimum voltage battery cell. That tells us that our battery temperature management system is not as efficient as it could be. And we could be getting better performance out of that battery if we improve the temperature management, particularly for cell number 1. And so this is real information we can use across hundreds of thousands or millions of vehicles to help us improve the performance of our cars. Once again, It's running live down at the GHS booth, so I encourage you to go there and take a look at it. Now turning to the question of features on demand. So in this case, we're looking at this part of the platform built on that eSync data pipeline. So the model here is to create an alternate front end for the OTA processes, where your customers will have some customer-facing mobile app or web portal where they will sign up for feature packages for their vehicle. The subscription manager will manage the monetization and the execution of how that feature platform is implemented in terms of what software has to go to that vehicle, and it will drive the OTA process to do that for you. Again, looking at a little bit more detail, in the subscription manager, you're going to have the authorization module, you're going to have what are the feature sets, you're going to have individual pieces of code that assemble together to make feature packages, you're going to have the monetization with a payment gateway, and you're going to manage the duration or expiration of subscriptions, and then all of that is used to initiate OTA activities through the standard eSync pipeline. So again, this is a platform that is now proven and demonstrated, and there are now vehicles just starting to ship that have this working in the platform. To take a look at what that would mean from the standpoint of the OEM, what you would be doing is you'd be driving an interface that's going to let you build your packages of features, create the pricing and policies for those features, and identify which devices and which classes of vehicles can subscribe to this feature package. And this can be done by model, by submodel, by geography. And then you're also going to get the monitoring of the results. So what has been the uptake on these feature packages? What is the update by geography? What is the update by how many subscribe to it? Which versions of the subscriptions, how many people are buying it permanently, how many are subscribing to the 1-month trial, you get to set all of that. And in your service environment, you can always drill down to the individual vehicle or the individual operator customer to see what feature packages they have subscribed to, what has been installed in their vehicle. So all of this works to drive the OTA process through the subscription manager. Now we have Fleet View for managing a fleet of software-defined vehicles, because this is a lot of stuff going on in the software in the vehicle. So how are you going to manage that? So now we're looking up at the top at the fleet level management. And so Fleet View gives you a front end for you to look at, for you to work from. A front end for eSync or eDatX and eDatX. It gives you visualization of the state of the vehicle. It's a software-defined vehicle. What software is in the vehicle? What software is in which vehicles? What software is in which devices of which vehicles? How do you look at a fleet of 1.5 million vehicles and know what software is in the braking controller of this particular build package? All of those cars in the field. This is what Fleet View is going to give you. It also gives you that same level of detail on the data that you're gathering through the eDatX platform. So the state of the vehicle. What is the state of the software? I want to be able to look at a fleet of millions of vehicles. I want to see them by family, by model, by submodel. I get the ability to drill down. There may be dozens, even hundreds of different SKUs of what I am deploying in the field. You get to see all of that through Fleet View. You get to drill down within one model or submodel to see the different technical domains of the vehicle. You get to drill down to see the individual devices within the technical domains of the vehicle. And to see how many vehicles are in OTA campaigns, how many vehicles the consumer has rejected the update, not taken the update, if there have been any errors in the OTA process. You get to see that not only by vehicle, but by individual device within the vehicle, within the domain within the vehicle. All of that is provided through the Fleet View drill down. That's on the question of the state of the software. Then we also do that on the state of the technical operation of the devices through eDatX. So once again, you get a drill down based on models and submodels and build packages of the vehicles, and you're looking here at DTCs, at diagnostic trouble codes, but also at your own definition of operational alerts. You want to know when something's happening in the vehicle. You may have decided just last week that you want to look at the temperature in the backup camera. Not wait until there's an error and the camera stops working, but let's just see what's happening across the fleet. If anybody's internal temperature goes above this threshold, tell me about it. That's what eDatX gives you as a technical capability, and that's what Fleet View gives you as a visualization. It also gives you the tools to build these kinds of custom data gathering and implement them as eSync OTA campaigns. So you define the data you want to get, you define what you want to do when you've got that data, and you define which vehicles you want to send it to. Can be one vehicle that's in the shop, can be 100,000 vehicles in the field. eDatX gives you the tools to do that. Same eDatX screens that I've been describing to you in the eDatX portion of the presentation, so that you can see that level of detail coming from the devices in your vehicle. Now, let's turn to our friends here. We're in the AWS booth, and let's see how this gets implemented in the AWS cloud. So what's going on in the cloud? All of the great services of the AWS cloud that we're using to implement this. For those of you who love the AWS cloud and its resources, here's a map of how we implement eSync in the AWS cloud. And in particular, I want to highlight a couple of features that we're using that help us provide this level of scalability. One is the elastic load balancing. So I talked about quick scale up so that you don't have to build a high cost basis to drive large volumes of vehicles. So we're using elastic scaling and elastic load balancing to scale up our solution set using eSync configured as a container in the cloud through the Elastic Kubernetes service, so that we can scale up eSync servers at need in the AWS cloud. So on an ongoing basis, you're never doing communications or connections with more than 10,000 cars in a day. All of a sudden you have found a cybersecurity risk. You want to update all the cars in the fleet as quickly as you can. You want to update 1 million cars in one day. The platform scales up to take care of that for you and then goes back to its normal state. And this is something that we do on a regular basis now. I'd also like to highlight the global reach. I mentioned earlier that we have millions of cars on the road using eSync on 3 different continents. We have cars in India, cars in China, cars in Europe, cars in North America. And the AWS cloud and the CDN constructs give us the ability to provide high performance connectivity in all of those regions around the world. So this is a part of how and why eSync works and scales so well. Now turning to a topic that will be probably of very high interest to a few, and that is the concept of the digital twin, and using the AWS cloud to build a continuous innovation, continuous development environment for your sophisticated algorithm development. And this is not simple stuff. And it was a lot of work that was done through cooperative efforts of AWS and the SOFI SIG and the AutoWare Foundation and the eSync Alliance, all working together. And what I'm going to be describing here was first presented at the ARM Dev Summit in November, just 2 months ago, in a master class. And what we're doing in this case, partnering with AWS, is building system parity for a server in the cloud, a platform in the lab, and the vehicle deployed in the field. So the AWS Graviton servers are built based on ARM processors. The SOFI eWall operating environment provides a consistent containerized model for ARM processors that can be deployed in edge platforms and can be deployed on the Graviton server in the cloud. eSync is now integrated with both the eWall SOFI platform and the autonomous driving stack provided by the AutoWare Foundation, AWS. So you have one software distribution environment that can seamlessly reach a digital twin in the cloud, a development system in the lab, and a vehicle, whether it be on your test track or deployed commercially. So the software distribution and installation mechanism is no longer a variable that differs between your dev environment and your deployment environment. You're using, it's again, reducing one more variable as you go into a CI/CD environment where you want to be doing continuous improvement and continuous learning to your autonomous driving stack. And this parity is actually being demonstrated in the booth. I think it's around the corner that way, where you will see over-the-air updates using eSync done to a digital twin in the cloud and a development system on the table. The digital twin in the cloud is a behavior pattern that is matched to the edge platform. So you're developing your environment, you're developing your technology, you want to see a new perception model for your LiDAR data, and you want to see your new algorithm. Does it work better? You've changed some things. How do you know if it's going to improve the identification of pedestrians? So you run it first in your digital twin in the cloud.
So you want digital twin
of the algorithms, of the software implementation. It's going to run on the same processor and the same stack that you have in your edge device. So you'll see how your algorithms perform first in the cloud, then you implement it into your lab environment and you see that it's working as you want it in the lab. Then you implement it in your test vehicles and you see how the test vehicles perform. Eventually, when you've got it to your satisfaction, you implement it in the vehicles in the field. You're using the same software distribution mechanism in all cases. So you're not injecting a new variable as you move from one case to the next. And this is all done by the joint work of the eSync Alliance, the AutoWare Foundation, and the SOFI SIG, and it's all built in AWS using the Graviton platform in the cloud, and then the ARM-based devices that you'll be programming on the edge. And we will be at the COVISA event this evening. I don't know if you're familiar with the name COVISA, the Connected Vehicle Systems Association. They have an event this evening at the Bellagio Hotel, and the eSync Alliance and the AutoWare Foundation have a joint display. We're allied with the COVISA. COVISA does data type, syntax, and format in the vehicle. That's of great interest to the eSync Alliance and the AutoWare Foundation. But this platform will be up and working, and we'll be doing live over-the-air updates to the LiDAR perception models in an autonomous vehicle stack based on the AWS stack, based on the eWall environment, and containerized eSync, all integrated and working, and you'll be able to come and see that this evening if you'd like. So, the happy part. How easy is it to get started? Right? This sounds like a lot, but it's surprisingly easy to get started. We have an agent SDK available on the AWS Marketplace. Now, this is going to give you a full working eSync implementation for your edge device. This is not you have to use our hardware. You get to choose what you're going to implement it to. You get an eSync client, you get an eSync server account on the AWS cloud, you get a template for an eSync agent. The client and the template for the agent are built for a Linux platform. You can do a Linux-based PC platform or a nice little, one of the smaller ARM-based platforms like Raspberry Pi. You install your eSync client, you build your own agent for your edge device by following the information that's provided to you on how to configure it for the type of edge device. You hook it up over a CAN bus, or hook it up over Ethernet, or hook it up over USB, however you want to connect to your edge device. The agent will be configured for your edge device and installed with the client, and you've now got a working eSync data pipeline to reach your edge device. We have customers who have downloaded this and got it up and working within an afternoon. So, if I made a reference earlier in my presentation, the guy who makes the ride leveling system is a long way away from the cloud. He's a long way away even from the antenna in the car. He's managing how smoothly the wheels go up and down when you hit a bump in the road. What does he know about connecting to the cloud? But there's a lot of interesting things he could do if he could get access to the cloud services and get data from his devices in the cloud. How is he going to do that? Ride leveling system, working eSync data pipeline. When he's done, he has an agent. When he goes to any automaker that wants to do an eSync pipeline, he's got an agent for his device and it plugs right in. So it couldn't be easier to get started. Doesn't mean you're going to start and finish here. You're probably going to come up with a lot of ideas for where this goes in time. But you get plugged in and you start building your familiarization with being in a connected environment for a software-defined component in a software-defined vehicle. You get to develop agents for your edge devices. You even get to go out to the world and show them that you know a thing or two about OTA because you've got it working and you're doing updates to your edge device. And it's all available right there through the Amazon Marketplace. So that concludes my presentation. If you'd like to ask questions, if you want me to dive in on any of these topics a little bit more, please come forward, speak up. I'd love to go in more detail. We have a few minutes left. Did you have any questions?
I have a lot actually.
And once again, I'd like to highlight, it's live and this is not theoretical stuff. Deployed in the field, here available at the show. You can go and see it working in highly complex environments and look at the data being drawn live from the devices and watch over-the-air updates changing the data that's being drawn. It's all here, it all works.